Today we want to solve Y past papers 2019. So the question will be displayed to you on the screen so you can look at the question and follow along as I solve the problem. 2019 Y past papers paper 2. So we're going to start now. The first question says that given that 110 sub x equals 40 sub 5, find the value of x. Now this is number based. This is 1a. They say 110 sub x equal 40 sub 5. So in number base, what you're basically going to do, you're going to multiply each of this value by sub x. So I'm going to have 1 times x plus 1 times x plus 0 times x equal, I'm going to do the same thing. I'll multiply each of the value by sub 5. So I have 40 times 5 plus 0 times 5. The next thing, I'm going to raise the power of sub 5 from 0, from my right down to the left. So this is 0, 1, the power will be increasing. I'll do the same thing for x from 0, 1, and 2. So the next thing, this is 1 times x squared will give me x squared plus 1 times x will give me x plus x raised to the power 0 is 1. 1 times 0 times 1 is 0 equal 4 times 5 is 20 plus x raised to the power 5 raised to the power 0 is 1. 0 times 1 is 0. So therefore x squared plus x minus, I'll take this to the other side so it becomes minus 20 equals 0. Now I have a quadratic equation, so I'm going to do quadratic by factoring. Now I'm going to do by factorization. So I'm going to multiply the first term by the last term. If I do that, x squared times minus 20, I'm going to get minus 20 x squared. The next thing is to break the x squared into x, and x here, x times x will give me x squared. So now after that, I'm going to look for two factors such that when I multiply those factors, it will give me minus 20. If I add or subtract the same factors, it will give me plus 1. I'm going to say that again. I'm going to look for two factors such that when I multiply those factors, it gives me minus 20. If I add or subtract the same factors, it will give me plus 1. So you can use prime factor to do that. This is 20, 2 here, 10, 2 here, 5, 5 here, 1. So now this is 4, 2 times 2 is 4 and 5. So if I say 5 times minus 2, 5 times, minus 4, I'm going to get minus 20. 5 minus 4 will give me 1. So that shows that 5 and minus 4 are the factor. Why? Because 5 times minus 4 gives me minus 20. 5 minus 4 gives me 1. Because what I said initially, look for two factors such that when you multiply it, it gives you minus 20. If you add or subtract the same factor, it gives you plus 1. So therefore, we're going to attach the factors here. This is 5 and then minus 4. Now the next step is that I'm going to replace 5x and 4x by minus 1, because 5x minus 4x will actually give me plus x. So I'm replacing these two by this. So if I do that, my expression becomes x squared plus 5x minus 4x minus 20 equals 0. Now I'm going to group them, and then I'm going to find the highest common factors. Now the highest common factor between x squared and 5x is x. The next thing I'm going to do, I'm going to say x squared divided by x will give me x. Then this is plus. I'll do the same thing, 5x divided by x will give me 5. Then this is minus. I'll find the highest common factor between this and this. The highest common factor is actually 4. So I'm going to say 4x divided by 4 will give me x. Minus minus will be plus. I'll do the same thing. 20 divided by 4 will be 5. So I'm going to write 5 equals 0. So therefore, because if you look at this x plus 5 must correspond to what you have in this bracket must correspond to what you have in the other bracket. So since they are the same, I'm going to pick one of them, x plus 5, then x minus 4 equals 0. So I can do this, x plus 5 equals 0, or x minus 4 equals 0. So x will be equals to minus 5, or x equals 4. So from the question says find the value of x. So we're going to take the positive side of x, the positive values of x, which is 4. So therefore, x is equals to 4. So that's the question, that's the solution for 1a. We're going to solve 1b now. So we want to solve 1b now. 1b says simplify 15 over root 75 plus root 108 plus root 432. Leaving the answer in the form of a root b. You want the answer to be in this form, a root b, where a and b are positive integers. Now what we're going to do, this is in sort. So, what we'll do, if you look at the root, with the root side, this is root, and root. So for the root side, now we're going to do this, assume this is over 1. So we want to find the LCM as if we have fraction. So, but we're going to solve the root form. We'll ensure that in this root form, we want to get one of the number must be a perfect square, but we'll make sure we take the highest perfect square. So let's start with 75. Now 3 here, we'll find the prime factors of 75. 3 here is 25. So I'm going to stop here because 25 is a perfect square. So 25 times 3 give me 75. So I'm going to write 15 over the square root of 25 times 3 plus. I'll do the same thing for 108. This is 254, 227, 3 here is 9. Oh, now I can see that this is 4 and this is 9. 4 times 9 is 36. 36 times 3 is 108. So I think I'll stop here. So I'm going to do the square of 36 times 3, then over 1 plus, I'm going to find the prime factor for the other one, 432, 2 here, 2, 1, 6, 2 here, 1, 0, 8, so 2 here, 54, 2 here, 27, 3 here, 9, 3 and 9, 3, 3 and 3, 1. So in this case, I'm looking at, this is 4, and this is another 4. So, well, now this is 3. 4 times 3 is 12. 4 times 3 is 12. 12 times 12 is 144, you can see that. So 144 times 3. So I'll just go 144 times 3. So therefore, now over 1. So here I have 15 over, the square root of 25 is 5, so I have 5 root 3, plus the square root of 36 is 6, so I have 6 root 3 over 1, plus the square root of 144 is 12, so I have 12 root 3 over 1. So I'm going to find a common denominator. The common denominator will be 5 root 3, just like finding the LCM. Now, if I do 5x divided by 5x will give me 1, 1 times 15 will give me 15. Sorry, 5 root 3 divided by 5 root 3 will give me 1, 1 times 15 will give me 15, plus 5 root 3 divided by 1 will give me 5 root 3. 5 root 3 times 6 root 3. I'm going to do 5 times 5, and 6 times 5 is 30, times root 3 is 3. Plus, I'll do the same thing here. 5 root 3 divided by 1 will give me 5 root 3. 5 root 3 times 12 root 3. I'll do 12 times. I'll multiply the number by the number and then the radicals by the radicals, which is a root form. So 12 times 5 is 60 times root 3 times root 3 will give me 3. So therefore, I have 15 plus 30 times 3 will give me 90 plus 60 times, so 30 times 3 will give me 90, 60 times 3 will give me 180 over 5 root 3. If I add all of this, I'm going to get 285 divided by 5 root 3. Now, if I reduce this 5 here one, 5 here will give me 57. So therefore, I have 57. Oh sorry, 5 here 1, 5 here 5. Here's 57. So I have 57 over root 3. Now, since I have 57 root 3, I'm not going to leave my answer in this form. Why? Because my denominator is in root form. So I'm going to find the conjugate by rationalizing the denominator. So I have 57 over root 3. Now, if I rationalize the denominator, it means I'm multiplying the numerator by root 3 and the denominator by root 3. If I do that, 57 times root 3 will give me 57 root 3 divided by root 3 times root 3 will give me 3. So 27 divided by 3 will give me 19 root 3. Therefore, the question says that my answer should be in form of a root b, where a and b are integer. You can see that a means this value, which is 19, and b means this value, which is 3. So the values of a and b are a is 19 and b is 3. So that's the solution.